Hello there, welcome back. Welcome back to the Technology Innovation Hub. It's going to be a session from DevOps portal. Let me share the screen. The last session, it was about Kubernetes, that deprecation of Docker on Kubernetes, deprecation of Docker runtime on Kubernetes. So if I just go back to the portal, I think we remember we have done that session. We went through the installation of container D as one of the alternative solutions for Docker runtime. So this is what deprecating Kubernetes is deprecating Docker runtime. And this video, I think the guideline and all them, because the installation document and everything is shared by now. And again, this is the GitHub document. Yeah. Yes, that's the guide for container installation, which we use in our session, in the previous session. And this one, of course, the manual creation, old one, because we created the cluster manually using the Docker runtime some time back. So if somebody want to refer to that video as well, it is there. I have given that because the second video, this session, Kubernetes deprecating Docker runtime, it is not covering the full installation. It is just addressing the new Docker, new container runtime, that is container D, the replacement for Docker. Okay, now today in our session, what we are trying to do here, we're trying to see the architectural analysis. Kubernetes Docker deprecation architectural analysis. So that is what we're going to do today. Because now we did the hands-on on last session, as I explained, but we need to understand what has really changed from the architectural perspective in terms of Kubernetes. And without right away jumping into the architecture, I have given certain information bit related to Docker history as well, the Docker evolution, the runtime, the Docker, because we always talk about container runtime. So we need to get an idea about container runtime as well. So let's go to the presentation. Of course, now you can see the new components, container D icon is here, and the CRIO, container runtime interface. O is for Open Container Initiative, the initiative which give the common specification for images. So let's talk about those things in more detail. Yeah, this is then, I think we had this slide, you may remember, because this presentation is just an enhancement from our old Kubernetes architecture presentation. You may remember we did the mid-senior architecture explanation. So these certain slides are available from that presentation, because this is just the enhancement on that. So these things you know about orchestration platform, so I'm not going to explain those things again. Some key terms, yeah, cheat sheet, that is about the kubectl command and node. And again, these are the basic terminology we went through on our architecture previous explanation. So if somebody want to go through that, you can watch that video. I put it as a reference on this session guidelines as well, so anyone can refer to that. So in this one, actually, the KubeCon, we know what is KubeCon. That's the annual conference which is held by Kubernetes, or the cloud native conference that is there. So they are holding annually this conference, and it is about to begin, I think 11th. So just one day left. Today is 10th, 11 to 15. So, and what I will do anyway, if there are any new updates from this session as well, I'll be uploading those things in our channel. So no worries about that, and you all can try to attend to this one. There are freely you can attend for certain session, not for all. Anyway, I'll be uploading the any new updates from this one as well to the channel. Fine. So let's go to. So I'm not going to explain this slide, because we have done this one in the architecture, and this one as well. I just kept those slides because to recall what we have done. And you may remember in our previous session, that is installing container D, we went on to these details, the 99 Kubernetes CRNF file, CRICNF file, and you may remember I get installed container D instead of Docker runtime. And these things also, the same steps, that is to initiate the K8 cluster on the control plane. And this is just joining the master node, worker nodes to the master node. Fine. So let's start the new stuff. New stuff means what is relevant for the current explanation and directly relevant for the Docker depreciation on K8 cluster. So this is the evolution of container runtime. So as I said earlier, we need to first get an idea about what is this container runtime. So it is all about that, no? Because now the topic itself says Kubernetes deprecating container runtime. So that's what the topic. So when you say, so you can see the word container runtime is there. So let's try to understand what is this container runtime is. So this is just a definition. So what it says, a running version of a image is a container, that we know, because you can compose the image in different methods. Docker compose is there and Docker build is there. So that is using Docker platform. Not only Docker platform, we have other platforms to build images, like Podman is there. So I'll show you those different platforms. Anyway, so once the image is composed, you are executing the image. So image executing means what? The container will come up. Container will come up so that the embedded application within the image will be accessible to the outside. So that is what. So running version of image is a container. That you all know. So container runtime. What is container runtime? Container runtime, it should maintain this running state. That is one of it. You can see a container runtime is a software which manages the container and maintains its runtime status. Okay, which manages the container. Yeah, it's true. It has to handle it, manage it, and link in all of the relevant libraries, and maintains the runtime status. That's true, because the container has to keep on running as far as end user is requesting it, as far as it is required to be up and running, and status by collaborating with the low-level components of the container engine. That's true. Because when you take the container engine, it consists of a lot of components actually. And container runtime is one part of it. So container runtime has to coordinate with the container engine in order to keep this container up and running. So that's what mainly the container runtime is. It is collaborating with the underlying operating system stuff, and collaborating with the underlying platform is related to container engine, and is trying to keep on running the container as much as required, as much as requested by the end user when it is deploying the container. So that is what, because we can't be confusing all the things by talking about orchestration platforms and all the things. Here the definition is given only to understand what is a container runtime. Because container runtime can be embedded within Docker, it can be embedded in Kubernetes, it can be embedded in other deployment platform, Nomad, SOS, those things are there. So that's just a component. We can take it out. So that is what actually now Kubernetes is doing. They had Docker as the container runtime. So now they are taking it away because it's a dependency. We will see why is that. Because it's a dependency and it came from Docker ecosystem or from Docker platform. So they don't want to keep that dependency. They are taking it away. And now what they are trying to do, they are replacing it with what? Open Container Initiative runtimes. So OCI, Open Container Initiative, means it's a generic specification for all images. Because if the particular container image is compliant with OCI, that means what? It is executable by any container runtime. So OCI compliant runtimes are there. So that is containerd is one of the OCI compliant runtimes. And again, CRIO. So let's talk about those things. So that's the definition for container runtime. So if you click here, I have a reference. So this is CNCF, Cloud Native Computing Foundation, because OCI is directly linked with CNCF. And you can see most of the open source projects are here. Now, if I click here, application definition and image build. So if I click here, now here you can see, these all of the softwares will give you the facility to compose images. Some of them are using Docker right away, because Docker organization, that was the one who started this container thing, I mean, in 2014. Before that, the LXC containers were there. But anyway, let's talk about that in a while. So these tools will allow you to compose images, container images. And again, most of them are depending on Docker, but there are things which is not depending on Docker. For example, we have Podman. This Podman is an example which does not depend on Docker because it has its own way of composing images. So it's a different, I mean, image composing platform. Docker image composing. We can't say Docker, right? It's image composing platform. And we can visit their website as well. You can see podman.io, and so likewise. So this is Podman. Okay, and so we have various different software, I mean, for composing images, container images. But Codes, Canico, Bitanami, those things are depend on Docker actually. Docker is embedded for composing images. Okay, so now we can talk about more on that. For example, if I visit to this website now, I think, yeah. So this is directly from Red Hat customer portal. Now they are talking about how to compose the image using Podman. And Scorpio and Builder is there because this is like to copy the container images, and Builder also allowing you to compose images, but there are certain dependencies on Docker. And Podman is a totally independent one which you can compose images. Yeah, in Builder also independent on certain ways. You can have independent images composed. Okay, so that is about that container runtime and some information related to composing images. Fine. So let's continue. This is the evolution of container runtime. So this slide will give you understanding about the history and the evolution of container runtime in the Docker terms. I mean, Docker path, how Docker came up in the history, and what is the evolution for Docker, Docker organization and Docker container. So let's talk about that. So very first thing, whether it's Docker or any other containers, in the container world, originally we had something called LXC containers. So LXC container is from Linux operating system. I mean, Docker is not involved initially. Initially, Docker also you depend on LXC containers to manage their containers. That is what LXC. LXC is the original. That is way back now. For example, was used before Docker 0.9. So Docker 0.9, that on 2014 only Docker getting reading, I mean taking away LXC from their platform. Then they are coming up their own technology called libcontainer. But before that, Docker also depending on LXC containers in order to compose images. So LXC is something like this. It is totally Linux. They had this container group concept, kernel namespace, and those things are there. I think we have a reference here. LXC containers. Yeah, this one. Okay. Now, if you go into that particular link, you can see Docker 0.9 introducing execution drivers and libcontainer. So that is on 0.9. So before that, they were heavily using LXC container. So if I go down, you can see this is the LXC technology. I mean, with Linux, you can see C group namespace or namespace. We have different types. We have the container namespace. We have the kernel namespace. And here they are talking about the kernel namespace, because with LXC, you can do virtualization without the assistance of a hypervisor, the middleman. Like, I think those things were explained in Docker session as well in the channel. Currently, if you say Oracle VirtualBox or VMware, always there's a hypervisor sits between the host OS and the guest OS. But LXC container, no need to have a hypervisor. They can right away have the VirtualBox virtual machine on top of the operating system. So that is another feature other than the containerization. So that is what Docker did from 2014 onwards. From Docker 0.9 onwards, they drop LXC as the default execution environment, and they introduce libcontainer. So after that, libcontainer continued, and what happened to libcontainer? And there was another thing came up with Docker, that is runc. We can say run compiler likewise. So runc, And that is linked up with Open Container Initiative, OCI. So that was I was talking about earlier, Open Container Initiative, which is defining a generic standard for images. There's a standard format for images. If it is OCI compliant, so it is a standard one, can be executed with most of the container runtime. So that's what. So runc is something like this. You can see is an abstraction in order to support wide range of isolation technologies, and a CLI is a command line tool. You can install runc and start working with that. CLI tool for spawning and running containers as per OCI specification. That's it, Open Container Initiative specification. So actually initially Docker developed this one and they handed over to the OCI. And so if I click here, you can see there's another click reference there. Introducing runc, that is 2015. Lightweight universal container runtime. That is what. So the explanation is given here. You can read it out. And again, so that's the second evolution. I think first one is lib container, and after that they came into runc. And so this, I mean, it's abstraction from the underlying technologies. I think especially with LXC, so dependency was totally taken away from LXC with runc. Yeah, most of the LXC containers were included in runc. Okay, so let's continue. After that, now what happened from runc? There was something within the runc called container D. So now the word comes. I think this is the same term that we are explaining on a practical, container D. So as a replacement for Docker runtime. So container D was initially developed with Docker again. You can see that now it is handed over to again OCI, Open Container Initiative, and CNCF. And so what initially these components were merged with runc, container D and runc were together, it is there. But what after that, what happened? Docker separated the container D. They took it away. You can see in 2016, Docker decided to separate the runtime component from the rest of the container DMS. Yeah, runtime component from the rest and the container D image. So that's why, because from rest of the component they separated container D, then container D emerged as a separate container runtime. And this is the Docker engine is there because you can, you can compose images, you can run them and monitor. It's a total ecosystem, Docker engine. And monitoring tools and composing tools, a lot of tools are included there. And container D is runtime, so that was separated. Whenever you want to run an image, container D was utilized. Even now, if you install Docker, it is using container D and it will get separately installed. Okay, so that is just a history from Docker, how Docker has been evolved, right? Evolution of Docker, how it, from the history, how it came up as of current. Fine, now let's continue to the next session. This is we are understanding container runtime. Yeah, we have another one. Now, container D is just one container runtime now. So other container runtime. So we have more container runtime. Let's take a look at it. Again, if you go to this CNCF landscape, so they are telling a lot of these things. But remember, these are only the projects which is CNCF. We have other projects, but most of them are here. That's okay. So if you go down here, you can see container runtime. So these are the container runtimes currently available, popular. We have container D. So this is container D, which I was just talking with Docker. And we have CRIO, container runtime interface. O means Open Container Initiative. And we have Firecracker. GWise is from Google. These are all runtimes, right? And LXD. And okay, so we have runc as well as a container runtime. That's okay. Yeah, so if I just click one of those things, and you can see again, you can visit their website and see. And this is not from Docker. This is a different initiative from different organization. I think it's from Red Hat and or yeah. So you can take a look at it, distribution packages or likewise. And CRIO Kubernetes pod. Okay, what is CRIO? CRIO is an implementation of the Kubernetes CRI container runtime interface. That's fine. It's an implementation of the Kubernetes CRI. Okay. To enable the OCI, Open Container Initiative compatible runtimes. It is lightweight. Okay, you can read and see Kubernetes Yeah, CRIO support OCI container images contributors. So this is what I want to say. You can see the contributors are Red Hat, Intel, SUSE. So these are the bodies behind it. So we don't need to go for architecture and more detail. But if you want to study, yes, it is there. And yes, CRIO is an implementation of the Kubernetes CRI. That's okay, because let's talk about what is Kubernetes CRI, Kubernetes Runtime Interface. We will discuss in a while. So that is a CRIO, one of the container runtimes. Okay, so now let's continue to the rest of the explanation. Now, what about Kubernetes and container runtime? So now I think we understood about Docker evaluation and Docker runtime, Docker evolution and Docker runtime. So let's talk about Kubernetes and container runtime. So I think we take a break here with this session and we continue in the next session. All right, so if you like the video, you can put a subscribe and let me start the next session soon. I'll meet you soon. Okay, have a great time. Bye bye.